Ladies and gentlemen of AGR 2470, we're at the halfway point of the agronomic crop production system part of the class, and so it's probably wise to take a moment and reflect on what we learned and where we're going to go in the second half of this portion of the course. So, what did we learn? Here are the key things you need to know. That's going to be questions on the final exam. Absolutely, you need to understand these things. First, this framework, the GEM framework to studying agronomic crop production systems. So genotypes, environment, and management, and most importantly, the interactions between these factors. You got to understand the concept, and then some of these key examples that I went over in the previous lectures. We also had a bit of a history lesson, how Canadian cropping systems changed over the past 100 to 150 years. You got to understand kind of the major differences, the major historical trends or temporal trends in Canadian agriculture. Next, we looked at trends across space, not across time, but how Canadian crop production kind of varies between, say, the prairies, the Maritimes, and southern Ontario, eastern Quebec. So you got to understand kind of the real key differences between crop production across Canada. We finally, or in the last lecture, we went over the 7 key laws that govern crop management and crop production decisions. This may have been reviewed for some of you. Some of these 7 key laws overlapped with things that Professor McAuliffe went over previously, but these are things that I'm going to ask you on the final exam, questions about these key laws. Okay, so that's where we've been. Now, in the next 2 lectures, and starting very, very soon in this lecture, we're going to cover virtually every crop management decision a farmer has to make to grow a given crop. And I'm going to focus really on the most common Ontario field crops. So that's going to be your corn, your soybeans, your wheat, but I'll throw in some other things. We'll see, we'll see where this goes. I'm not even sure yet, but we're going to focus on the main crops, field crops in Ontario, and I'll throw some other stuff in. So we're going to really focus on the M component of cropping systems and how management is going to interact with genotype, how management is going to interact with environment. Okay, so of the G, E, and M, this second half, we're focusing really on the M component. Now, the way I'm organizing this section is chronologically. So we're going to start with the first management decision a farmer has to make for a given crop, and then all the way to the last, which is essentially harvest. Now, you might think the first decision starts around planting, but it really does not. In fact, the first management decision, and I'm not being hyperbolic here, I'm not exaggerating, the first management decision a farmer makes when growing a crop starts the second they're harvesting the previous crop. So why do I say that it starts the second the previous crop is harvested? It has to do with residue. That's the answer. Now, what do I mean? Let me explain this a bit. So here you see some photos of common Ontario field crops that have reached physiological maturity. That means they're essentially dead. The grain's not growing. They're ready for harvest. They're drying down. We'll talk a little bit about what drying down means probably towards the end of the lectures. They're ready to get harvested. Let's think back for a moment to the yield equation that we covered in the previous lecture. The yield equation has a component called the harvest index, which is the fraction of the total crop biomass, that crop that is going to be harvested, essentially the grain. And everything else that's not the grain, we're going to call residue. It's stover. It's not harvested by the farmer. It's left out in the field. So you can see here you have on the top left, you have a photo of a cornfield. The bottom left, you have soybeans. On the top right, you have one of my favorite movies, Gladiator. That's Maximus walking through his wheat field, ready to get harvested. The bottom right is oats. These are all crops that are going to leave literally tons of residue. That's going to be the cobs, the stems, the chaff, etc. Everything that's not the grain is essentially left out onto the field, with a very small number of exceptions. So these are some numbers from the Ontario Ministry of Agriculture that I pulled together. Typical residue levels that a farmer has to deal with in Ontario. And these numbers apply also probably to Quebec and other states in the Northeast United States. So corn after harvest, you're dealing with 10 tons of residue per hectare. Soybean, it's about half that. Wheat, it's the lowest of these 3.3 tons per hectare on average. Of course, this is variable, right? But this is give you a sense of what amounts of residue are left over after harvest. And corn is typically the most heavy residue crop that's grown, field crop that's grown in Ontario. So the first decision a farmer has to make is, how do I deal with this residue? How do I use it to my benefit? How do I avoid potential problems that residue can cause for my next crop? So we're going to give an overview of what are the benefits and potential drawbacks of residue, and then how do farmers manage it. Now, because this is an introductory class, I'd be remiss if I didn't kind of explain what you're looking at right now, which is a combine. Okay, this is a farm machine that does the harvesting. It separates the grain from basically everything else, from the pods, from the chaff, or from the stover, okay, from the husk. Now, basically, a combine, very complex machine, but the one part you should know what's going on here. Actually, two parts I'm going to say. First is the head. That's what travels in front of what's being driven and collects. It's the first thing that collects the grain and harvests the grain. Next is what you can kind of see are the wheels. Now, some of these are wheeled and some of these are tracked. And you can see here there's actually some tracks on these combines. And so this is kind of interesting, right? You have this machine that sometimes runs on wheels, sometimes runs on tracks. And we're going to talk a little bit about why much later in this portion of the course. So what happens to residue? The combine passes over the field, it spits out the residue out the back end of the combine. And what happens? Well, essentially, it stays on the surface of the soil if a farmer doesn't do anything, right? It's going to stay on the soil. And here you see examples of different residue, post-harvest residues. Now, when this residue stays on the soil, it confers one primary benefit to that farmer and to that soil, which is it reduces wind and water erosion dramatically. And the data is actually very clear. This is a tweet from a former Honors Ag OAC student who graduated a couple of years ago. This is a photo he took. A generous neighbor is helping raise our organic matter today. Only takes one windstorm a year to do significant damage. The ground needs to be covered 365. So what we're looking at here is in winter a field that has a bunch of soil, very light dusting of topsoil on it. And so this soil was clearly deposited after it snowed. So this is a cause of wind erosion during the winter. Basically, there was an uncovered field that was not covered either with residue or a cover crop or something else. And so the wind just took that soil, that topsoil, very rich in organic matter, lots of nutrients, and deposited it onto a neighbor's field. So what we have here is wind erosion. And the clinical definition of erosion is the detachment of soil particles from the soil surface. I'm not going to ask you to memorize that. Just know this is what wind erosion looks like, and residue cover can minimize this. And I'll give some numbers later to back this up. Here you see an example of water erosion. It's a similar concept that soil's leaving the field, except not via wind, but via water. So there can be runoff erosion if you have a heavy rainfall. Water is going to flow and take soil with it. But you also get erosion just via regular rainfall on bare soil. So you can see here's a figure where a soil particle, basically those raindrops act like a bomb, exploding these soil particles. And these small soil particles are microscopic. You can't see them, but when it rains, these soil particles can be launched up to 3 feet in the air, and that can add to wind erosion. It can also just make it much easier for those soil particles to be lost. And so what residue does is that essentially acts like a mulch. It's a protective barrier preventing wind and water erosion from occurring. And there's been a number of studies done, lots of them in the 60s, 70s, and 80s. This is when erosion it's still a big problem, but it was a huge problem in many parts, especially in Western Canada, erosion was a big problem. So a lot of research done, and these are averages across studies, but on average, compared to just having a bare soil, leaving the full residue of a cereal crop like corn, wheat, or oats, leaving that on the soil surface reduces erosion by 95%. For soybeans or other legumes that decompose more rapidly, there's not as much residue after harvest. This number is about 65% versus bare soil. So still a huge reduction in erosion. And so overall, having the soil covered, even 20-30% covered with residue can reduce erosion substantially. And so the graph here that you see says, you get about 50% erosion reduction with 20% soil residue cover. Okay, so this is a number one benefit of residue, reducing erosion. The second benefit that residue provides to the farmer and his or her field is that it is the main input for soil organic matter. That's the organic or organic fraction of a soil. Remember, soil, as you recall from previous in this course, soil is made of silt, sand, and clay. There's also an organic carbon fraction, soil organic matter. And generally, there's a number of benefits that soil organic matter provides to farm fields and to crops. I won't go into those in these lectures, but in any soil science course you take at this university and really anywhere in the world, you'll learn about the importance of soil organic matter. So in field crop production, crop residues are the main input, the number one input for soil organic matter. And I'm ignoring things like manure, which come from animals. Main input for soil organic matter. Now, think about it. The residue comes off the combine. It's on the soil surface where it's reducing wind and water erosion. But eventually, over time, that residue is going to turn into what we see here, right? Well, we'd see the organic fraction of a soil. And that happens via decomposition. It's a microbial process, okay? So it's happening because of bacteria and fungi in the soil that it's degrading and essentially eating that residue. Now, Ontario research suggests that, say, after about 10 years, you're going to have around 10% of the plant residue, the carbon in that plant residue, is going to remain in the soil. The rest is going to be respired as carbon dioxide. Okay, those soil microbes are breathing out. Well, they're not really breathing out, but for the purpose of this course, they're respiring. They're breathing out carbon dioxide, just like we would breathe out carbon dioxide as our bodies respire. And that carbon dioxide is lost from the system. It's not part of soil organic matter anymore, but about 10% of the carbon is not respired. It stays in the soil, and it's considered organic matter. Now, over time, as you increase residue inputs into a soil, you're going to also increase soil organic matter. So if, say, yields increase over time, and therefore the amount of residue increases over time, going back to the yield equation, as yields increase, higher residue returns. Over time, we're going to get a buildup of soil organic matter. But it's a very, very slow buildup, okay? This is not something you can notice from one year to the next. Now, this is data from a study done in Iowa, 4 locations in Iowa, but it's just illustrative of what's going on. So they looked at, in continuous corn, residue carbon inputs. And remember that of plant residue, about 40% of that residue is made of carbon atoms. The rest is things like nitrogen or hydrogen or oxygen, phosphorus, etc. Okay, so about 40% of plant residue or crop residue is made of carbon. And so when you convert plant residue to carbon and you look at residue carbon inputs in continuous corn, what you can see here is it takes, for example, 5 megagrams of carbon. Okay, that's 5 tons of carbon to get 0.2 tons of soil organic carbon increase. So if you're inputting 5 tons of carbon in a hectare, you're going to get 200 kilos of soil organic carbon after all said and done. The rest is essentially respired by the microbes. So this is a very slow process, but this is a major benefit that residue provides. Buildup of soil organic matter. Okay, so far I've been explaining to you all the benefits of residue. So, maybe you're asking yourself, well, residue's so great. Why is this a problem? Why is there a management decision? Just get as much residue as you can as a farmer, and that's about it. But there are actually some downsides to residue, keeping that residue on the soil surface. And so that's why it causes trade-offs that farmers have to make decisions about. So what are some of these downsides? First, residue on the soil surface acts as a mulch, keeping the soil cooler and wetter than otherwise. So that residue, while it's protecting the soil from erosion, basically insulates it. And so it keeps it much wetter and much cooler, especially during the fall and spring during the planting season. Now, this might be a huge benefit depending on where you are in Canada, this mulch effect of residue. So if we look in the prairies, for example, this is Saskatoon. You've seen these before in a previous lecture. When you only have 300, 400 millimeters of rain in a growing season, you really want to keep that soil as wet as possible. Okay, you're really trying to manage moisture and minimize any moisture loss. But in Ontario, basically everywhere in Ontario, we get abundant and well-distributed rainfall. We're getting 1,000 millimeters of rainfall every year. Okay, so twice as much as say in the prairies, if not more. And because we get more rainfall in Ontario and the rest of Eastern Canada is similar, then our soils are somewhat almost too wet. They're in fact too wet in the spring, and farmers manage, and we'll talk about this later, they try to dry out their soils quick in the spring so that they're able to plant. And cold soils reduce germination. They slow down the emergence of a crop. And so you don't necessarily want a cool and wet soil in the spring when you're trying to plant. You want a relatively dry and relatively warm soil to plant into. And residue on the surface prevents that. So possible downside in Ontario. There's a number of other things we can talk about residue. I mean, I have a whole lecture in my 4th year course, but some other quick downsides. First, it can act as a habitat for insect pests. So, slugs in no-till are pretty well known in Ontario. They like the moist and shaded conditions, and so you typically get more slug damage on seedlings in a no-till versus conventionally tilled field, where there's just a lot less residue or no residue on the surface. Residue also poses a problem during planting, like a physical problem with the planter. It can prevent good seed to soil contact and reduce germination and emergence, and thus lower the crop stand. We'll talk a little bit about that. And most farmers that want residue, they're no-till farmers. They don't till. They have lots of residue. They adjust their planters to deal with this, but it is a problem, and it slows down germination, emergence. It can cause hair pinning, etc. We'll talk about that more. But otherwise, you can see, look, this is a soybean crop emerging in a no-till field that just had corn. You can see all the residue. You can't even see the soil, and you can see, look, this is great for reducing erosion, but it does cause other issues. So this is the long and short of it of why a farmer needs to decide right after they combine their crop what to do with the residue. And so a couple of things, right? I'll go over the most common decisions that they make, at least in Ontario. The first most common one is to bury and incorporate that residue via tillage. Now, there's a number of reasons to do tillage, but in the fall, especially, a primary reason is this, just to reduce the amount of residue on the surface, especially after a crop like corn in Ontario, which has tremendously high amounts of residue on the surface. So what you see here is a farmer, and he's decided to basically do tillage. In the foreground, you see the combine rolling, harvesting corn. In the background, you can see someone else running a tillage implement, essentially burying and incorporating that residue. And so there's many different kinds of tillage implements a farmer can buy and use. I won't go through them all here, but we can think of them really in two categories. First is what we call aggressive primary tillage, and that's what would happen here in the fall. You're really trying to turn the soil over. You're trying to literally bury that residue into the soil so it can decompose quicker. Because remember, decomposition happens because of microbes. And so the closer that residue is to the soil where those microbes are living, it's just physically closer. You'll get quicker decomposition. They're away from the soil surface, so they're not acting as a mulch. So you get this aggressive or primary kind of tillage from a moldboard plow or a chisel plow. And then there's lighter tillage, what you could call maybe very vertical disc tillage, field cultivators that are not aggressive. They're just kind of what a farmer would say is tickling the soil surface, but really they're just trying to mix a little bit of, they're not trying to bury that residue, they're just trying to mix it up. But let's say they're going to go with very aggressive primary tillage. They're burrowing and incorporating. So you're going to go from, say, 60% residue cover. That's typically what you get after, say, no-till corn after a wheat harvest. Corn harvest or after a wheat harvest, you'll end up with something like 60% residue cover. And after primary tillage, no matter what implement is used, after primary tillage, you end up with around 10% residue cover. Okay, so it's basically completely buried. Now, a farmer can choose to do what you would call reduced or a more secondary kind of tillage, where they're not just fully burying and incorporating the residue, but they're trying to manage to get aim for around 30% residue cover after harvest. That's what OMAFRA recommends. And if you remember back to that earlier slide, 30% residue cover gives you an over 50% reduction in erosion over winter compared to bare soil. So while not 60% residue cover is great, 30% is still very, very good. And so farmers will try minimum tillage to get some of the benefits of residue, but also reduce the harmful effects of residue on their next crop. Now again, many different kinds of reduced tillage or what we call secondary tillage implements. Vertical tillage, for example. Here what you see is what's called a strip tiller. Now what a strip tiller is doing is it's only tilling strips of the soil. It's tilling about 30 to 50% of a field. The remaining half, it's not being tilled, and it's essentially all that residue is staying right on the soil surface. So here you're trying to get the best of both worlds. Now, the idea is that when you come back in the spring and when you're planting, the farmer is going to plant right into those tilled strips. You can see I made those red arrows. The farmer is going to put the seeds right in that area because it's cleared of residue. So ideally that strip is about 5-6 degrees warmer. It's slightly drier, and so it's much better suited for germination and emergence than say right beside it, 15 inches beside it, where there's still a lot of residue. So this is called strip tillage. I'm not going to test you on anything about tillage implements. Just know that there's primary aggressive tillage and secondary much lighter tillage. And this is an example of that more lighter tillage or reduced tillage. Now, just to give you a close-up of what more aggressive tillage looks like, this is a moldboard plow. This is full inversion tillage. And you're just completely flipping over the surface of that soil, and you're completely burying, it would be residue. Here it's a grass pasture that you're just completely burying, okay? And so if you're completely burying something with aggressive tillage, you're not going to get 30% residue cover. So this is these are some decisions a farmer has to make. A farmer can also decide just not to till. And if they consistently do not till after any of their crops or at any point in their crop production, they are no-till farmers. They just never till. And that's a management strategy that I would say is much more common in Western Canada than it is in Eastern Canada. But of course, there's quite a few farmers in this province that are no-till farmers. Now, some farmers are strategically no-till, or I would say tactically no-till rather. They will till or not till depending on the crop. So it's easier not to till in the fall after crops that leave very little residue after harvest, or if they have residues that decompose very quickly. And a great example of that is any legume like your soybean or dry beans. So they will technically produce quite a bit of residue. Soybeans, for example, are going to start producing residue, even before they're harvested as those leaves fall off and drop to the ground. But because it's a legume, it has a very low C to N ratio compared to cereals. You'll learn about this in another class. But because these legumes have very low C to N ratios, they decompose very quick. And so the residue after harvest is very minimal. It's easy. You don't necessarily have to till. Whereas with corn especially, and also with cereals like wheat or oats, not tilling after those crops, there's a lot more residue to deal with that can cause problems. So In your education at the University of Guelph, you're going to hear many soil scientists and many other, scientists at the OAC tell you about the benefits of no-till. That it has all these benefits: no-till, no-till, no-till. I want to counteract that a bit and say, well, hold on, right? In Ontario, I would say maybe 25% of farmers are no-till. The majority, the vast majority, do tillage. And even those that would call themselves no-till might do some tillage every now and then if they need to. And we'll talk about that later. So, farmers till for a reason. If they don't till, there can be a yield drag for the next crop. If they don't till, well, how are they going to deal with herbicide-resistant weeds? They can't spray a herbicide. Typically, you would use tillage to kill those herbicide-resistant weeds, but you can't do that in a no-till system. And indeed, farmers that are completely no-till are very reliant on herbicides to deal with their weeds. Many other things, which we'll talk about later. How do you incorporate fertilizers to bury and incorporate fertilizers to prevent nutrient runoff and pollution? Many other things, okay? So there are good reasons why farmers do tillage. There's good reasons why farmers do no-till. And so I just want to push back before you take all your soil science courses at the university. There's good reasons why farmers do tillage. Okay, so the popularity of no-till. So in Western Canada, I'm talking about, Saskatchewan, Manitoba, Alberta, virtually all farmers are no-till farmers. But that's because no-till dramatically increases yield, right? If they can keep their residue on the surface, then they can better use their limited amount of rainfall, the limited amount of soil moisture they have to grow crops. So no-till is very beneficial, and a bunch of new technologies came out in the 70s, 80s, and 90s that allowed farmers in Western Canada to move to no-till. New types of planting systems that allowed them to plant and cut through residue. New herbicides that let them, get away with not tilling but still dealing with weeds. Okay, in Eastern Canada, it's much less common, and there's no good, I haven't seen any hard stats what percentage of farmers in Eastern Canada are no-till. It's actually, hard. A farmer who calls himself no-till might do some tillage, and then what do you call no-till versus minimum till? So this is my kind of guess based on conversations with OMAFRA extension specialists and other agronomists across Ontario. I would say, 30% or less, say 25-30% of farmers in Ontario or Eastern Canada are no-till. So, another question, and again, you're going to hear in your soil science classes that no-till can actually increase soil organic carbon. And, there's lots of benefits for crop production for the farmer to have high soil organic carbon. With climate change, this is even bigger issue, right? Because if you can sequester carbon in the soil, then, it's not in the atmosphere, and that's great for climate change. So does no-till increase soil organic carbon sequestration? Now, there's been quite a bunch of studies done in Ontario, across Canada, across the world. What does tillage do? In Western Canada, the evidence is quite clear that no-till increases soil organic carbon sequestration. And here you can see, on average, this is the annual soil organic carbon rate of change across Canada. This is from a 2019 study, very good study. And you can see in Western Canada, those main agricultural regions, organic carbon's going up over time. Slowly, right? We're talking about 0.5 to 2% a year at most. But if you look at Eastern Canada, it's actually going down slightly. Again, very slightly, but a 0.5 to 1% decline in soil organic carbon. And so many people will look at this and say, well, hey, it's because people in Western Canada do no-till, people in Eastern Canada do tillage, and that's the reason why. But the evidence suggests that no-till in Ontario does not increase soil organic carbon sequestration more than conventional tillage. What it does is increase soil organic carbon in the topsoil. But because farmers that do tillage are burying and incorporating residue, they increase soil organic carbon throughout the top 30 centimeters of the soil profile instead of the top 10 or 15 centimeters. And so when you adjust for soil profile depth, when you look at the whole soil profile, conventional tillage and no tillage perform very similarly in terms of soil organic carbon sequestration. So A final thing that farmers can, and I'm almost done, folks. I'm almost done on this topic. I know I beat it to death almost, but there's a couple of other things farmers can do with residue. Now, one of the things they can do is just straight up burn that residue. They'll just burn it. Now, that's almost never practiced in Canada. In other countries like India, they'll burn their wheat residue. They want to get rid of it as soon as possible because in places like subtropical India or even more temperate regions of India, they can double crop. And so they want to get rid of that residue and get the fields ready for the next crop that they're growing. That doesn't happen in Canada, virtually never. What happens is some people are going to bale or remove that residue. So they're going to either, for example, here you see people baling corn stalks to use as feed. You can see people will bale hay, bale straw, so bale wheat straw, the stems of wheat. They'll use that either for bedding, they can use that for feed. And I know a student, a couple of years ago, a student was had a little bit of a side hustle. They were getting these small square bales of straw, very clean straw, and selling it to brides, women, people having their wedding, I guess, grooms and brides that were having their wedding, if they're having a country wedding or they wanted some square bales for decor, people to sit on, guests to sit on and take pictures on. And I remember her telling me, the best part about it is she could get a couple square bales and she could reuse them 4 or 5 times or however many times before they got too dirty. And so she was getting a lot of use out of renting these bales. So you can bale this residue off and monetize it, sell it for feed, or use it for your own livestock. Anyway, I've spoken way too long. Actually, no, just long enough on residue. Let's move on to the next decisions a farmer has to make.